new topic is chain rules for functions of several variables. The chain rule goes like this, even with partials. If you want to find the partial of w with respect to t, you can, now, if you have many different functions of t, x1 of t, x2 of t, x of 3 of t, x1, x2, x3, they're just names. I could use x, y, and z. Don't. No, x of t is in terms of t. 2t plus 1, 2t minus 4, 7t to the 5th over ln of t. Then dw dt would equal dw x1 times the partial of x1 with respect to t. You could, although this doesn't cancel out like in basic algebra, you can think of it that way. And you're left with dw dt. Plus, there's another function of t. It's called x of 2 times partial of x2 with respect to t. Plus, the partial of w with respect to x3 times dx3 dt. If there's many functions of t, if there's 3 functions of t's, you're going to get 3 of these. How do you know there's 3 functions of 2? There's the first, there's the second, there is the third. You can see them. They are right there. Okay, that's enough for the lecture. Suppose I give you a function and I ask you to find d partial w dt. Suppose that you come to know that w is equal to e to the 2t excuse me, that would be silly. Suppose w is equal to x squared plus y squared. But x is a function of t, and y is also a function of t. So then, the partial of w with respect to t, since we have 2 functions of t, x and y, I'm going to add 2 terms, dw dx. Since that's x, I'm going to put partial x, partial t. It's almost as if that cancels out and you get dw dt. Plus, we have a second function of t. So it's dw, or partial w, with respect to y, times partial y, partial t, dt. Okay, well, dw dx, the partial of this with respect to x, that's just 2x. The derivative of x squared is 2x, plus the derivative of y squared with respect to x, that's a constant, times dx dt. The derivative of this with respect to t, just e to the t, plus partial w over partial t, over partial y, excuse me. The derivative of the top, the partial derivative of the top with respect to y is just 2y. The derivative of x squared is 0, times partial y t. Actually, what I'm writing isn't exactly correct. The second half would be dx over dt, dy over dt. Then I'm taking partials. When I'm about to take dy dt, there's only y's and t's. We're not holding any variables constant. dy dt is negative e to the negative t. So now we're down to algebra. I can clearly factor out for 2. And then what's left is x e to the t minus y e to the negative t. Now, it's nice to have the answer in terms of that letter, t. But it's not. Like, for example, I see x's. Well, I know how to write x. X is e to the t times e to the t. Why, that's e to the 2t minus y, which is e to the negative t, times e to the negative t again, which will give you e to the negative 2t. And there's the answer. It really should be a function of t. Sometimes you just won't be able to get that, but you should try it. And since most problems that you're up against, for now at least, are from a textbook, they're kind of rigged so you can eliminate the x's and y and then just get the answer in terms of t. Okay, so what if w is the function of x, y, and z? It's x squared plus y squared plus z squared. So x is a function of t. It's that. And y is also a function of t. And z is also a function of t. Now, we want to find the partial of w with respect to t. But w is not in terms of t. That is, we're going to have to do the partial of w with respect to x times dx dt, plus the partial of w with respect to y times dy dt. How do you know what letters to put here and here? They're right there. That's where you look. Plus partial w with respect to z times dz dt. Well, the partials are easy. The partial of w, that means I look at w with respect to x, that's 2x. The partial of w with respect to y is 2y. For z, it's 2z. We need to find dx dt, dy dt, etc. Well, dx dt, since it's a product, since x is a product, dx dt, to calculate dx dt, we use their quote product rule. So you can actually factor out the e to the t. It's the derivative of the first, which is e to the t, times the second, plus the first times the derivative of the second, which is minus sine the t. Why will e to the t always be able to be factored out in a product rule? Because first, you take the derivative, and you're going to get e to the t. And then, you don't take the derivative, and you get e to the t as one of the factors. So e to the t will always be a factor. Okay. You get 2x times e to the t times cosine t minus sine t. Cosine t minus sine t, plus partial of w with respect to y is 2y times dy dt. But this is going to be very similar. Still a product, and one of the factors is e to the t. So first you write down the second factor plus the derivative of the second factor. So it is, well, I meant to write sine t, but I'll get away with that. Plus d partial w with respect to z, that's 2z. And the derivative of z with respect to t, that is the derivative of that with respect to t, is just e to the t. Okay. And this here is partial w with respect to t. The only problem is that it has letters other than t. It has x's and y's and z's. It's amazing how many letters it has. Well, we're going to get rid of them. Equals. Now first, I hope it's clear that you can factor out a 2 from each of the terms. And each of the terms has an x. Well, one term has an x, one has a y, another one has a z. But when I look at x, y's, and z's, they all have e to the t. So I'm going to factor that out. And of course, I left out e to the t right there. The derivative was this. I only wrote this down. That's a typo. So now, so I have x. I wrote down the 2, and I wrote down part of x. The rest of the x is cosine t times this, times cosine t minus sine t, plus, I factored out the y. I meant to say the 2. I factored out part of the y. I factored out the e to the t. For y also has sine t. Sine t. I'm trying to take shortcuts and it's not working. I factored out the 2. Each of the letters x, y, and z has an e to a t in it. So I factored out the e to the t. I have this left, e to the t, cosine t minus sine t, times the part of the x I didn't write, which was cosine of t, plus. I wrote down the 2. I'm going to write down the e to the t. Part of the y I wrote down in front. I wrote down the e to the t, but I didn't write down sine of t. Sine of t times this mess. Cosine t plus sine t. Plus, I wrote down the 2. I wrote down part of z. Well, actually, z was just e to the t. Plus that e to the t. Okay, so we have this. In fact, I can even factor out e to the t from inside the brackets. Every term. The terms are separated by addition and subtraction symbols that are not in brackets. They each have an e to the t factor. They each have e to the t. So I'm going to factor it out. So I'm going to have e to the t times another e to the t. That's e to the 2t. Okay, so this isn't here anymore. This isn't here. And this is times 1. And the e to the t is in there. Okay. Now we have cosine t times cosine t, better known as cosine squared t, minus cosine t times sine t, plus sine t cosine t, which is the same as cosine t sine t. You take something away, you add it back, even if the order is not the same, you get 0. Plus sine squared t, plus the 1 at the very end. The thing is, this plus that is 1, plus another 1 is 2. So this mess gets multiplied by 2. So it's 4e to the 2t. What's in these big brackets is just 2. What's in these big brackets is 2. 2 times 2 is 4, times e to the 2t is 4e to the 2t. The Calc 3 part isn't a big deal. Big deal is the earlier calculus plus the algebra. Now, in this next problem, we want to find partial w with respect to s and partial w with respect to t. And you're told that w is equal to x squared plus y squared, and x is equal to s plus t, and y is equal to s minus t. So x and y are functions of s. And for the next problem, t. So partial w with respect to our s. Well, this is partial w with respect to x, and then partial x with respect to s. And the reason the second one is partial, because x is not just a function of s, it's a function of s and t. Okay, plus the partial of w with respect to y, and then partial y, partial s. Now to calculate these four, multiply and add them. Partial w with respect to x. Well, with respect to x, the derivative of x squared is 2x. Plus, with respect to x, that's the constant. Derivative is 0. 2x plus 0 is just 2x times dx ds. The derivative of this, just in terms of s, is 1. The derivative of s is 1. The derivative of t is a constant, and a constant is 0. Plus dw dy. X squared is a constant now, plus, so its derivative is 0, plus the derivative of y squared is 2y, times dy ds. Well, in terms of s, the derivative is 1 minus, the constant is 0. 1 minus 0 is 1. We get 2x plus 2y. We get 2 times x plus y. We get 2 times x plus y. That's x, that's y. Because I would like my answer to just involve s. So you have s plus t, that's x, plus s minus t, which is y. Fortunately, the t's actually cancel. And s plus s is 2s times the s in the front gives us 4s. So that half of the problem is done. That is, we found partial w with respect to s. Now let's find it again with respect to t now. So partial w with respect to t is partial w. Well, you have x in terms of t times the partial of x with respect to t, plus you have w, you have y in terms of t, so that's why y gets down there, partial y, partial t. Partial y with respect to t. So the first one you know, we already did it. It's 2x. Partial of w with respect to y, we already did it. It's 2y. So start to notice that you already have the answers. You don't have to keep inventing the wheel. dx dt, I look at x and I take the partial with respect to t. S is a constant, its derivative is 0. T is not, its derivative is 1. dy dt, the derivative of negative t, negative 1t if you prefer, is negative 1. 2x times 1 is 2x. Positive 2x times negative 1 is positive 2y times negative 1 is minus 2y. You factor out the 2, you get x take away y. But x is s plus t minus y, s minus t. You have s and you take away s, you have 0 s's. But if you have t and you take away negative t, you have 2 t's. And here the answer, is that true? Yeah, I was thinking you had negative 2t. You do have t. 2t. And 2 times 2t is 4t. So we found both partials. Partial w with respect to s and partial w with respect to our t. And that's all I ask. That's all I ask you to do. Okay, these problems just take a while. They're not as quick as taking a derivative of a polynomial like we did in Calc 1. Now, there are 2 ways, for example, that you can find partial w with respect to t. Maybe you can't always do this, but when you can, you can. If w is equal to xy plus xz plus yz, and they want you to find that. And they tell you that x is equal to t minus 1 and y is equal to t squared minus 1 and z is just good old t. Now there are 2 ways of doing this. You can say partial w with respect to t. First you do with respect to x and then times dx dt plus the partial of w with respect to y, those letters, times dy dt plus the partial of w with respect to z times dz dt. The second factors are not partial because x is just a function of t, not s and t, for example. Same for y, same for z. Okay, w sub x. Remember, this is w sub x. The derivative of this with respect to x. Well, there's x, and that's the constant. The derivative of that is y. It's a constant. Plus, that's a constant times x. The derivative is just a constant. This is just a constant. The derivative is 0. So I just found partial w with respect to x. Now I multiply that by dx dt. The derivative of this with respect to t is just 1. Plus, now the partial with respect to y. This here, y is the function, x is a constant. The derivative of a constant times x is just a constant. Excuse me, constant times y is just a constant. Here, in this term, there are no y's. That's just a pure constant. You add on the derivative of that constant, which is 0. You add on 0. No need to even really write plus 0. Okay, plus, now we take the derivative of this. There's y. Z is a constant. Z times y. A constant times y, the derivative is just a constant. Times dy dt, which is 2t. Plus the partial of w with respect to z. Well, in x, y, there's no z's. It's just a constant. The derivative is 0. Plus the derivative of xz. Z is the variable, x is a constant. The derivative is just a constant. Same in the next case. You have yz. Y is the constant. The derivative is just y. Times dz dt. The derivative of t is just 1. And most of their products we don't have to really worry about. Multiplying by 1 is straightforward. Here we have to multiply by 2t. So you get 2tx. I don't know why. I'm going to say the x at the end. Plus 2zt. Plus that times 1, which is just that. X plus y. I guess I can combine like terms. First comment I'll say is I didn't need the brackets in the front. And what I will say is that y way up front plus this y at the end gives us 2 y's. That collected like terms. And put the calculus is now done. But we have x, y's, and z's. My goodness. We would just like to have t's. So you get 2 times y. Reading our translations on top, y is t squared minus 1 plus z, which is t. Maybe I should have said the t first. You have 2t times x, where x is t minus 1, plus 2t times z, where z is t. Times by another t, you get t squared. Plus x, which is t minus 1. I'm really going to stop here. You should distribute out, collect like terms. Like over here, we'll get 2z squared plus another 2t squared plus another 2t squared, that's 4t squared, plus those t squares, that's 6t squares. How many t's we have? We have 1t minus 2t, that's negative 1t, plus t, it's no t's. And then you get minus 2, minus 1, so minus 3. So I lied, I did it for you. That's one way of doing this problem. It wasn't so easy. Another way of doing it is to get w in terms of t. That is, so we're done, we did it, we're done, we're happy. Now we're going to try another way. We're going to substitute back right away. X times y. X times y is t minus 1 times t squared minus 1 plus xz. This is t minus 1, that's x, times z, plus yz. I'll write the z first, and y is t squared minus 1. Now I'll multiply out. I get t cubed minus t squared minus t plus 1 plus t squared. I'll write them right here. Plus t squared minus t plus t cubed minus t. It wasn't that bad. We have t cubed plus t cubed, 2t cubed. You take away t squared, and you add it back, there are none. Then you take away t, and another t, and another t. You took away 3t. This is w in terms of t. Okay? Let me get rid of everything on the bottom except the answer. Okay. We now have w in terms of t. Okay, it says w equals this, which equals this, which in terms equals that, which ultimately equals that. That's what w is. W is now a function of t. Since it's only a function of t, no partials. dw dt is 6t squared minus 3. Same answer I got down there. So you can substitute back. You can substitute back. And I guess from the very beginning on all these problems, minor typo, we're finding dw dt. Okay, now dw dt, that equals the partial with respect to x dx dt plus partial with respect to y dy dt. Now, if x is only a function of t and y is only a function of t, then you don't have to put the partial symbols. You don't have to say partial y. You can say dy over dx, or dt, excuse me. But if x is a function of t and other letters, then it's partial. Okay, so we did the problem two ways. We got the same answer. You can always at least try to eliminate the parameters, x, y, and z in this case. Get rid of them. Or just bring in one parameter, t. So now, they want us to find dz, dy. They want us to find dz, dy. And we'll talk about whether or not that symbol is correct. Suppose you come to know that the tangent of x plus y plus the tangent of y plus z is 1. Now, we want to take the derivatives with respect to y. So the derivative or tangent of anything, it is secant squared of the anything times the derivative of the anything with respect to y. X is a constant. The derivative of y is 1 times 1 plus the derivative of the next piece. The derivative of the tangent of anything is the secant squared of the same angle times the derivative of the angle. The derivative of y with respect to y is 1 plus the derivative of z with respect to y, that's dz dy. And this equals the derivative of 1 with respect to any letter, in particular y, is 0. Okay, so now we want to collect their like terms. We have secant squared x plus y plus 1 times that, which is just that, plus dz times that, partial z partial y times secant squared y plus z. And this equals 0. We want to solve for this. So first you solve for that term. You bring the other two terms to the other side. Partial z times partial y times this mess. It equals, bring this to the other side. It's just algebra. Bring this to the other side of the equal sign, it becomes minus as well. And then divide by how many partial z's with respect to partial y's you have. It is divide the left side by secant squared of y plus z, just to cancel it out. And then the left side is just what they're asking you to solve for. Before you forget, do the same thing to the right side. And there's your answer. When they tell you to find partial of z, then when you take the derivative of z, it's not a constant. But since they did say partial z with respect to y, you think of x as a constant. Okay, if they would have said instead find partial x with respect to y, then I would have said the derivative of that is partial x partial y plus the derivative of y is 1. Instead of just having a 1 here, I would have had that. And over here, when I would have said that z is a constant, and the derivative of z would have been the 1. Would have been 0. I would have had just 1, not 1 plus partial z over partial y. Okay, that's the key step. Rewind the tape, listen to that 30, 40, 193 times. And you understand that if you look out for that, you won't have any troubles. Only if they say find dw, only take the derivative when you see w and x's. Other things are called constants. Even if they're a letter, they're now a constant. Okay. Let's consider this next problem. They want us to find all partials, all first order partials. So you come to know that x squared plus 2yz plus z squared equal to 1. The thing is that this is even implicit, because it doesn't say z equals. Because then we would find zx, zy, and we'd be on. We'd be on our way. But it's not z equal. Remember before when it was y equal x squared plus 3x, you would just take the derivative and say that wasn't bad. But at some point it didn't say y equal. It said x squared y is equal to y cubed over x plus 1 minus 11x over y squared. Okay, this was done implicit. So let's take the derivative first with respect to x. And our goal is to find dz dx, dy dx, I meant to say dz dy, dz dy. Just like when you had x squared y is equal to 3x cosine of y, and they say find the derivative, they wanted you to find y prime. Now, in 3 dimensions, they want you to find z primes. But since there's different letters, it's z sub x. That's like z prime, but I'm telling you with respect to what letter. And here's another z prime, but we have to say with respect to y. So, we just don't write z prime sub x. It's redundant. It's understood that when you see that little subscript x, it means derivative. Okay, so first, we're finding dz dx. So taking derivatives with respect to x. Y is a constant. Okay, the derivative of this is just 2x plus, here's a constant, times the derivative of z with respect to x. So the derivative of x squared is 2x in terms of x with respect to x. That cancels out. Okay, plus the derivative of z squared is 2z. It's in terms of z with respect to x equals the derivative of a constant has always been 0. Okay, let us solve for dz dx. So these two terms have dz dx. Let's bring that over. So I know the right side is minus 2x. The left side, how many dz dx's do we have? Well, here we have positive 2y, and we are adding 2z's. Okay, little algebra. I'm going to factor out the 2 from the left side of the equation, and I'm going to factor out the 2 from the right side. And then I'm going to divide both sides by 2. So I have that y plus z dz dx is negative x. Divide by y plus z, and there is your answer. There is your answer. Now, I'm going to find it with respect to y. X squared is a pure constant. I want to find ultimately dz dy. Anything other than z's and y's are constant, like x. Okay, so the derivative is 0. Plus this. That's a product actually. Y, I'm going to factor out the 2. Y times z, that's a product. So partial is the derivative of y, which is 1, times the z, plus the y times the partial of z, which is dz dy, plus the derivative of z squared is 2z in terms of z with respect to y. And the derivative of 1 is 0. First thing I would do is I would divide both sides, all 3 terms by 2. 0 divided by 2 is 0. So now I have 1z plus y partial z dy plus z partial z dy. I'm going to bring the z to the other side as negative z. On the left side, I can factor out what I want to solve for. I can factor this out. I have y of them, and I'm adding z of them. I have y plus z partial z's with respect to y. Then you divide by this number. or expression. There's the answer. Partial z, partial y is negative z over y plus z. These are called the single partials. The double partials, if they asked us to find, a double partial would have two things on the bottom, like maybe dx as well. Or partial z over partial y times, again, partial y, which is just denoted partial y squared. Those are called double partials. They asked for, they said find all the single partials. That was the problem. Given that equation on the top left, x squared plus 2yz plus z squared equals 1, find all the partials. And we did. In fact, let's find the double partials. So here was the equation, not that it matters. 2yz plus z squared equals 1. And we concluded that the partial z with respect to x was negative x over y plus z. I remember correctly, with respect to y, we got negative z over y plus z. So now I want to find some other partials. I want to find partial z over partial x, partial y. That means now I want to take the partial of y of what I just had. That is, I have partial z with respect to x. I want to take the partial of that with respect to y. That is, I want to take the partial of this. With respect to y. Now, since the numerator is not a function of y, this is not Calc 3, this is Calc 1 what I'm going to talk about. Since the numerator is not a function of y, I will not use the quotient rule. I would just bring it up in the numerator. And then, now remember, that's the constant. That's the constant. So you bring this down, you get positive x. You make that new power 1 less, which makes it negative 2 in the numerator. If I put it in the denominator, I can write positive 2. And then you need to multiply by the derivative of what's inside. The derivative of y is 1, plus the derivative of z is partial z over partial y. But we have that answer. We have that answer. It's 1 plus partial z with respect to y. It's this answer. It's negative z over y plus z. Okay, now, my favorite stuff, algebra. I'm going to change the way this looks. That means I need to multiply by 1. I don't like, in my numerator, which is above this line, I don't like the fact that it has a denominator. It has a y plus z as a denominator. Okay, this x stays. 1 times this is this, y plus z. The negative z over y plus z, the y plus z's cancel, and you just get negative z. Coincidentally, even the z's cancel. And in the bottom, you have y plus z squared times y plus z. that's better known as y plus z cubed. And since what's in the brackets, y in the numerator, y plus z minus z, that's just y. X times y is just xy. And there it is. xy is on top. And you can go and find the partial z with respect to y with respect to x. So we do this one last. That is, we take the partial with respect to x of partial z, partial y. zy is this. So it's the partial with respect to x of negative z over y plus z. And since we have either x, we have x and z's on top as well as on the bottom. I mean, there's no x's, but there's z's on top and on the bottom. I would use the quotient rule here. Okay, but I'm not going to do this one. You have to have some exercises to do yourself. Okay, so they want us to find the first partial derivatives of this. xyz plus xzw minus yzw plus w squared is equal to 5. Now, if you have a function, like if you have a function of x, they say call that y. And if f of x is, and you should only see x's, 3x squared minus 4x plus 5 divided by ln of x plus 2. This is y. This is y. And when you have a function of two variables, that means what I write in here better just have x and y. It's like x squared plus 3xy cubed over x squared minus y squared. We call this z. Now, I find it amusing how the mathematicians, being so brilliant as they are, they run out of letters. If you have f of x, y, z, well, over here, you better see only x's, y's, and z's. Like 3x, y, z squared, plus 7z. They run into letters because, for example, we call this y. X, then y. This is a function of x and y. What came after y is z. This here is a function of x, y, and z. Oh, there's no letter after z. That's what I meant when I said they ran out of letters. But they call it w. Unless otherwise stated, a function of x has always been called y. A function of x, y is called z. This is called w. Okay? When we take the partials, we're taking the partials of w. We're taking the partials of w. Oh, why do I know that? Because this is the function of 3 variables, actually 4 variables. The fourth variable, just like the y was, when we were in our pre-calculus. So, let us first find w sub x. When they say find the first order partials in this 4 variables, x, y, z, and w, we have to find wx, wy, wz. Let's try to find wx. That is, we're taking the partials with respect to x. X and w are not constants. yz is a constant. There's x. The derivative of a constant times x is just the constant. I mean, you can say the derivative of x is 1. It's in terms of x with respect to x. But that's going to cancel out. You can say it if it makes you happier, for real. Plus, z is the constant. This is z times xw. The derivative of xw being a product, it's this derivative of x, which is 1, times w, plus x times the derivative of w, which is dw dx. Okay. Minus yz is a constant. The derivative of w is partial w, partial x, plus the derivative of w squared is 2w, partial w with respect to x. The right-hand side, the derivative is good old 0. I did not mean to put an equal sign here. Okay. So first, we'll clean up. yz times 1 is yz. Plus, 1 times w is w, so it's plus zw. Plus zx, w sub x. Just different notation. Minus this. yz, partial w with respect to x, plus 2w, w sub x. It's like we're writing y prime, it's like writing y prime or dy dx. w sub x is like the y prime, and the partial w with respect to, say, x, that's like the dy dx. It's just notation. You need to get that down. Okay, so I want to collect the terms that have w sub x, namely these three. The first two terms I'm going to bring to the left. So how many w sub x's do I have? Zx minus yz plus 2w. And I bring the other two terms to the other side and I change the signs. And understood positive yz becomes negative yz minus zw. And wx is just the left side, the right side. I'll even factor out the minus, divided by this number or expression. And minus some silly error, here's the answer. Look, okay, there's the answer. And you can find w sub y the same way and w sub z the same exact way. I've been doing a lot of problems. I'm not going to convert this into 3 different problems. Though that's what it is. On that note, this section is actually completed. Chain rules for functions of several variables. Good luck with it.